discuss about what is RFID, what are the different application of the RFID, what is inside this RFID chip, and how this RFID works. So, first of all, let's start with what is RFID. So, this radio frequency identification or RFID is a technology which is working on radio frequency of radio wave. So, this technology is used to automatically identification the object or tracking the objects. The object could be anything. The object could be books in a library, or it could be any item which are purchasing from the shopping mall, or it could be the inventory of the warehouse, or maybe it could be own car. Not only the object, it can be used for tracking the animal as well as the birds. So, in this RFID technology, the RFID tag is used to get attached to the object which it wants to track. So, this RFID reader is continuously sending radio wave. Whenever this object is in the range of the reader, then this RFID tag used to transmit its feedback signal to the reader. It is very similar to the technology which is used in the barcode, but in case of the barcode, the object and the scanner should be in line of the sight. As this RFID technology is not a line of sight technology, so as far as this object is within the range of the reader, object is able to identify the reader and is able to send the feedback signal back to the reader. By using this RFID technology, we can track even multiple objects at the same time. Now, let us see what is inside this RFID system. As we have discussed, this RFID system contains two components. First, RFID reader, and the second, RFID tag. RFID tag also coming in many ways. This RFID tag could be active tag, or it could be passive tag. This passive tag do not have their own power supply. It is relies on the radio wave which is coming from the RFID reader for the source of energy. While in case of an active tag, they used to have their own power supply. But for transmitting the signal back to the reader, also they are relying on their own power supply. So, as this passive tag do not have their own power supply, so the range is less compared to the active tag. First of all, let's see what is inside the RFID reader. RFID reader are coming in many size and shape. It could be your handheld reader, or it could be as large as the size of the door, which normally see inside the shopping malls. This RFID reader mainly consists of three components. The first component of the RFID reader is RF signal generator. This signal generator generates radio wave which are transmitted using the antenna. Also, to receive the feedback signal which is coming from the tag. The RFID reader also have a receiver of signal detector to process the information which is being sent by the RFID tag. This RFID reader also have microcontroller on, or in many times this RFID reader is directly connected to the computer. Next, let's see about the RFID tags. Most of the tags which are being used today are passive tag because it were quite cheaper compared to the active tags. They also do not require any power source, so they are quite compact. It's also coming in many forms. It could be either the size of keychains, or could be the size of credit card, or maybe it could be in the form of label. Let's see what are the basic components inside this RFID tag. The first component that you will see inside the RFID tag is a transponder, which receive the radio wave which are coming from the reader and send the feedback signal back to the reader. As the passive tag do not have their own power supply, so they rely on the radio wave which are coming from the reader. They used to get the energy from the radio wave which are coming from the reader. By using this rectifier circuit, The energy that is coming from the radio wave is stored across the capacitor. This energy is used as a supply for the controller as well as the memory element inside this RFID tag.
So now let us see the working principle for this RFID system. So before we see the working principle, first let us have a look at different frequencies at which these RFID tags operated. So mainly, these RFID tags are operated at three types of frequencies. First, the low frequency, second, high frequency, and the third, ultra high frequency. So this range of frequency of operation varies within countries, but majority of the countries use these frequencies for the operation for RFID tags. So as these low frequency signals can travel very short distance, so the range of RFID tags which is using this low frequency is up to 10 cm. High frequency can travel up to 1 meter, while the ultra high frequency radio wave can travel even further distance than the rest. It can travel between 10 to 15 meters. And now we will see the working principle for this RFID tag. This working principle also depends on the frequency operation. For low frequency and high frequency operation, the working principle is based on the inductive coupling, while in the case of ultra high frequency RFID tags, the working principle is based on the electromagnetic coupling. First of all, let's have a look at the inductive coupling. This reader will continuously sending radio wave with a particular frequency. These radio waves which is being sent by this RFID reader serve three purposes. First, it induces the sufficient power into the passive tag. Second, it provides synchronization clock for the passive tag. And the third, it acts as a data carrier which is coming back from the tag. So the field which is generated by this RFID reader is used to get the couple with antenna of RFID tag. And because of this mutual coupling, the voltage will get induced across the coil of the tag. Some portion of the voltage is getting rectified and used as a power supply for the controller as well as the memory elements. As the RFID reader is sending a radio wave of a particular frequency, so the voltage that is induced across the coil is also from the particular frequency. This induced voltage is also used to derive the synchronization clock for the controller. If we connect the load with this coil, then the current will start flowing through this load. And if we change the impedance of this load, then the current that is flowing through this load will also change. Then if we switch on and off this load, and the current will also get switched on and off. The switching of current or rate of change of current also generate a voltage in RFID reader. This method of switching load and off is called load modulation. Next, if we switch on and off this data according to the data that is stored inside this RFID tag, then that data can be read by RFID reader in the form of voltage. By using the load modulation, we are changing the voltage that is generated across RFID reader coil. The result is that we are generating modulation on carrier frequency. With this technique, the data is being sent back to the reader. The working principle for ultra high frequency, as a distance between the reader and the tag is up to few meters, so the coupling between reader and the coil will be far field coupling. This RFID reader will continuously sending the particular frequency to the tag. Thus, the tag is sending back a weak signal to the reader. This weak signal is known as the backscattered signal. The intensity of this backscattered signal depends on the load matching across the coil. If the load is matched perfectly, then the intensity of the backscattered signal will increase. Therefore, by changing the condition of a load, we can change the intensity of this coil, of this signal. And if we change the condition of a load according to the data that is being stored across the tag, then the data can be sent back to the RFID reader. Thus, the reader will be able to recognize the data. As we decrease the distance between the tag and the reader, so the initial signal which is being sent by the reader should be strong in this powerful coupling, and the backscattered signal can be retrieved back by this reader. The application of the RFID is used in a wide range of fields, and many of it we have already discussed, such as institutions like hospital, school, transportation and logistics, access control, sports and animal tracking. The system of RFID is also applied in advanced product tracking, quick convenience, safety and security, and easy access. For advanced product tracking, it will provide the real-time data management and dramatic benefits to manufacturing process. For quick convenience, such as grocery store, library, hospital, instant identification and time saver. Safety and security is the system of RFID will be able to locate or identify the missing person or monitor prisoners in prison. For the easy access, the RFID system will access by authorized personnel only, and it will ease the security concerns. So as the conclusion, the RFID system will provide efficiency, durability and security more than any other system available. However, the disadvantage of this system is that the materials, the reliability and the cost and implementation is quite highly in cost.